Hello, everyone. My name is Adam Hems. Warm welcome this evening. Folks still coming in, coming down, sit down. Warm welcome. My name is Adam Hems, and I'm the lead of the user group this evening. Getting some food here, so there might be some pizza eating noises for those of you who are online. Sorry, virtual pizza doesn't taste that great, but sorry. We're having a bite here. While we get settled. Those of you online in Houston, let's come out, have some pizza this time. Right, so for those of you who are new to the group, everyone in the room has been here before, so we've got a lot of familiar faces. Welcome. I've got some names on the. I don't recognize everyone online, so for those of you who are new to our group. My name, like I say, Adam Hems, and this is my hobby, one of my hobbies. My day job is actually as a cloud architect at Microsoft. I took over this group in 2016 when the leader moved on. He left Houston, and so I wanted to help bring the community together and help folks learn from stories of cloud journeys, because the technology is the same. Ever evolving, but the technology is the same. But and so for many people, the journeys are as well. But the business problems are what are different, right? And stage through the journeys are all different. And these days, out of this huge toolkit we have with Azure, which tools amongst all of those we have to pick from? Folks to continue to do business problems require different tools within the toolkit that available for us in Azure. So. The intent of this meetup is to learn someone, not intended to be any kind of sales pitch of any kind, or marketing, anything like that. Marketing are kind enough to let me use the room. That's nice. We've got some stickers here we give away, and that's pretty much it. So other than that, it's very much intended to be a community event where we learn from one another. My favorite presentations often have colleagues help me out with presentations. Those are great. My favorite kinds are when members of the community present. We have such today in the form of Jacob. And without further ado, let me hand it over to our speaker tonight.
Awesome. Thank you, Adam. Greetings, everyone. How's the pizza? Everybody good? Cool. Can everybody hear me okay?
Yes.
Awesome. So quick show of hands. How many people have heard of Airflow before?
I have, yeah.
Cool. Anybody used Airflow before themselves? Okay, no worries. Does anybody manage data pipelines at all, like moving data from one place to another? Cool, excellent. So you guys are in the right place. A little bit about me before I jump into the technology. Jacob Martin, here's my contact information. I've been with Astronomer for 6 months now. Astronomer is the steward of the Airflow open source project. It was originally started by Airbnb. It's an open source Python-based data orchestrator.
Hey, Jacob, I don't see you presenting on screen. You're up here, but I don't see you on Teams. Could you have another go presenting your screen on Teams?
Yeah, it says it is. It's like a marked red. Let me stop it and start again.
And can see us.
Is that working now?
Can't see your screen. We can see you, but not your screen.
Yeah, I shared this one, and the red box popped up around it. But from my perspective, I don't know. Are you on the Teams in the back? Could you see if it shows up for you or not?
Sure. I'm seeing your picture.
Oh, need to mute, Ken. Yeah, we can see your video,
But not the,
yeah, you are not sharing your screen.
you want to come take a look?
Yeah, let's try and figure this out. Kind of limiting for folks online if we can't.
There.
So
Hit open share tray. This is my other screen down here. Yeah. It says stop presenting.
Fine. Fantastic, that works.
So if you want, I could run through and just make a recording of it later to post up.
Yeah,
If you want.
yeah. Let's not waste any more time.
Okay.
Well, yeah, we're gonna have to. Yeah. I don't know why. I can't see it. I can what I can do. I'll put my camera on
Oh, okay, cool.
and capture the screen that way. 1 second.
Well, Adam's working on that. Another quick question. How many people here use Docker already on a regular basis? Does anybody have Docker locally on their laptop, desktop, or is it just, okay, cool.
Ask many complicated questions, then don't use it to that level.
So the reason I ask is that Airflow, the tool that we're using today, that I'm going to be demoing, there's lots of different ways you can deploy it. It's kind of like Kubernetes. You could run it in the cloud, on-prem, on your laptop, and you can run Airflow really easily on your laptop if you have Docker already installed. So if you want to follow along, you can certainly do that. Yeah, I'll just continue real quick.
Yeah, go
I'm
ahead.
an astronomer. I've been here about 6 months, still very much learning the ropes in the data engineering space. My background is more on the Linux security, traditional automation side. The stuff that I'm going to show tonight is how to use Azure Data Services orchestrated from Airflow to ingest and consolidate data from the City Bikes project. City Bikes started, they wanted to make a mobile app that tracked all of the different bikes and where they were available in the different places. If you've got different bike providers in your town, rather than having to look on each app individually, they wanted to make this big data set real time that covered all the bike providers that were out there. And so we're going to use that public API to ingest data scheduled from Airflow, and then use various Azure data services in the process of doing that. The City Bikes API is pretty straightforward. It's a standard public REST API. The Azure data services we're going to use are the data lake storage or the traditional blob storage. We're going to use the HDFS interface to access and store blob objects there. Is there anyone here who's not familiar with Azure Blob Storage? Yeah, skip that one. Databricks, anybody work with Databricks or Spark in the past? Well, so essentially Spark is sort of like a Pandas, but like distributed. So it's like a library or a framework for doing analysis on kind of tabular data sets. Pandas is what people tend to use for smaller data sets locally. Spark allows you to do that in a much bigger distributed manner. And then Databricks is the commercial steward of the open source Spark project. So kind of like Databricks is to Spark, Astronomer is to Airflow. We're going to do a little bit with Azure Data Factory. That's a graphical, like no-code approach for orchestrating data workflows natively in Azure. It's got a really cool upsert task that we're going to use. Upsert is kind of a combination of insert and update. So with a lot of traditional databases, they're not really set up for idempotency, like where you could run the same operation over and over again simply and get the same result. But with an upsert, it's a combination of insert and update. So if the record you're inserting doesn't exist, it's just a normal insert. But if the record does exist, then upsert will treat it like an update and it'll apply your changes to the existing row. So it's a modern thing that other databases are starting to implement, but Azure Data Factory has it out of the box, and it's really cool for that. And then we're going to be using both the Astronomer version of Airflow and an open source local version of Airflow at different points in the demo. Right, so ultimately, this is what we're going to have. It's going to be a web-based orchestrator where you can feed the relationships and dependencies between the different tasks in the pipeline. Airflow itself, it's really the de facto standard for data orchestration. It's platform agnostic. It originated in Airbnb. It was open source in 2015. Airbnb is very much a data-driven company, and they had a lot of challenges orchestrating data and kind of democratizing data across the organization. And Airflow really helped them accomplish that. It's currently used by over 1 million data engineers, and it's very unbiased in terms of how everything's implemented. From a high level, the Databricks, they have a model they call the medallion architecture, where your data moves from like bronze, silver to gold, where bronze is the raw data that you have. Silver is where you deduplicate it, get it structured in the way that you want. And then the gold layer is where it's refactored and presented to all of the business intelligence users. One of the big strengths of Airflow in general is that there's a massive library of providers, so that out of the box, it can talk to almost practically any data source or destination that you would need. But a common question I get is, why Airflow? I mean, if you have any kind of a Unix or Linux background, you already know how to schedule things. This is a data engineering intern. Took 3 days to transfer from Healthy Young Actress to Wednesday Addams from the Addams family. Has anybody here ever had to maintain someone else's cron job? Yeah, that's pretty painful. I know, Houston, you worked on some of each other's cron jobs back in the day. And it's a pretty painful process. Cron is really awesome for what it is. It's a super reliable scheduler, but that's really all it is. If you want to schedule a job to run in one box and the job is relatively simple, cron is pretty good for that. But as soon as you need to scale out past what you can do on one machine, you're having to do all of that manually. There's no monitoring or reporting unless you set up your own custom log capturing system. You're going to be reading your local Unix mail on each machine where cron runs. It's purely text mode. There's no way to visualize how all of your jobs are doing. If you give a cron automation task to 10 people, you're probably going to come out with like 13 different ways of it being done in the end. And then there's no standards for a lot of the common things that you want in an orchestrator, like the ability to backfill. Like, let's say you've got a data pipeline and it runs every hour. Maybe let's call it every day. And you come in on Monday and you see that the jobs over the weekend failed. You want to be able to backfill, basically go back and execute those over again, just on the actual data set that they were supposed to see at that time. And that's something you don't get out of the box. Other things like parallelism, retries, task dependencies, you don't get any of that with cron. We already talked about the Airbnb story a little bit. Why do people like Airflow so much? It's Python native. Python is the standard language for most data engineers and machine learning today. It's so popular, it's already become a common interface between the different stakeholders within sort of the data ecosystem at a lot of companies. It's sort of the one platform that they all understand. There's a ton of integrations already, so that you don't have to write a lot of code out of the box. You're essentially plugging existing operators together more than you are having to like code support for specific APIs. And there's really good monitoring and learning that it comes with. There's a public registry where you can go download providers. There's 97 of them today. The Azure provider has pretty robust support for the Azure platform. Azure has way more services than the provider supports at this point, but we've really tried to focus the provider around the API endpoints in Azure that people are most likely going to use with Airflow. Kind of see some stats here. The Azure provider alone has over 100,000 downloads a month, which is actually fairly representative of how much people are using it, or just a fraction of that. Most of the time, people are building that Azure provider into a Docker image. So every time the Docker image runs, that's not included in this number, so the actual like uses of it are quite a bit higher than that. So any questions at this point? So Airflow 101, the essential idea of Airflow is a graph database. So when you're creating a data pipeline, you're probably going to have a number of steps in there. Each one of those steps is represented as a node on that graph. And then the dependency relationships are the vertices of the graph database. We call them DAGs in Airflow nomenclature. That stands for directed acyclic graph. For a DAG to be valid, it has to be directed acyclic, meaning no loops, and of course it's a graph. So this is an example of a valid DAG. These two are not valid. On the left, it's invalid because it's got a loop. The second one is invalid because there's no direction to it. You want a starting point and an ending point. So your the execution path will follow like a predefined known state, and it's not possible to get into a thing where you have an infinite loop based on some edge case. So that makes it a lot easier to troubleshoot from an operational standpoint. Another concept is runs. So every time the pipeline executes, that's called a run. This is the grid view in Airflow. Each vertical column in the grid view represents a run that happened at a particular point in time. The labels on the left side are the tasks within that DAG. And then altogether, the grid view shows you the status of all the tasks and all the runs that have happened within the time period that you're looking for. And this is one of the places where it's like way better than cron, because just at a glance, you can tell, okay, it's been running really well for the last 6 days. We had some problems the last week, and the week before that, it was all good. So you immediately know kind of what's going on, how things are going. Down one level from DAGs, you have tasks of the individual steps inside of a pipeline. This could be something like loading a data set into Blob Storage. It could be calling an Azure Databricks notebook to process that data. Calling an Azure Data Factory pipeline to run, things like that. The life cycle of a task, there's a few states that it moves through. Won't read all of these, but they're all color coded. So once you're familiar with them, you're looking at the Airflow dashboard. It's really easy to see what the state of each of your pipeline executions is. The core components of Airflow, there's a web server running Flask that you interact with when you're clicking around in the UI. The scheduler is responsible for keeping track of what time it is and the desired schedules for all of the DAGs. The Metastore database stores all the information about the pipelines that are running. And then there's a variety of executors that you can use depending on the deployment. If you're running locally, it's going to be the local executor. In production, people will typically run either Celery or Kubernetes. Another big concept in Airflow and best practices around idempotency. So this is sort of like where you're defining what you want your data set to look like, as opposed to making incremental changes to it based on the state that it was in. Has anybody used Terraform? The cloud infrastructure? Yeah, so Terraform is intended to be an idempotent tool. You write what you want, and Terraform is responsible for making your infrastructure look like that. It's possible to write Airflow DAGs so they're non-idempotent. I don't know what the antonym for that is. But it is possible to do that, but idempotency is what you're really aiming for. The idea being that you can, at any point in time, go run a backfill job to say, if things failed on Saturday, we'll just go run it again for Saturday on that date. And if it has to be retried from failures, it won't create any big problems for you. One of the challenges that people face with Airflow oftentimes is it's kind of challenging to install on your own just from open source. So astronomers made what we call the Astro CLI. It's a freely available tool anybody can use, and it will spin up pre-configured local development environments using Docker on your local system. And let me see if I can get out of here and show what that looks like. So the Astro CLI, it'll be familiar to you if you've used anything like Terraform or Vault. It's got a hierarchical command structure. You can do an Astro dev init to create a new project. I've got one here. Can you guys read this okay?
Big up, please, Jacob. Big up. Yeah, they're good.
So this is what an Airflow project structure looks like. We've got a very simple Docker file that pulls in the astronomer base image. There's an Airflow settings YAML. The DAGs directory is where you put all of your pipelines. In Airflow, the pipelines are defined as Python code. And then if you have any customizations that you need to put in there, you can include extra OS packages. Like if you wanted the Azure, the AZ CLI, if you're going to be making calls to that. Then any Python libraries would go in the requirements file. And if I do an astro dev ps, we'll see that we've got all of those core components running that we discussed earlier. Excuse me. Sorry about that. And then if we do a Docker PS, we can see all of the containers. There's normally only 4 here, but I've got some additional things added in for instrumentation. So we've got Nginx running TLS for certificates on the front end. Then we've also got Prometheus and Grafana so that we can see some more in-depth stats on the back end. So this is the Airflow UI running on my localhost environment. And you can see we've got a variety of pipelines here in different states of execution. But I'm going to jump over to our Airflow in Azure environment. And this is the City Bikes pipeline that we were looking at earlier. So, or that we were talking about earlier. So there's a few things that we're going to do here. First, out of the available providers that we have, kind of a list of them, we're going to make a random selection with the decide providers task. That's going to go into an API poll using something called dynamic task mapping. So a lot of times, if you have big data sets that you're going to process, you don't want to do that all within one job because it'll take a long time maybe, and it won't use all the compute that you have available to you. With dynamic task mapping, you can split up a data set into any number of pieces and then run it in parallel. So we're doing that with the API poll. So of the random locations from the first task, we'll pull the City Bikes API in parallel to get one from London, one from Houston, one from New York, whatever. And then we'll store those API results in Blob Storage. Then we'll kick off a Databricks transform job. This is that Azure Databricks to take that raw JSON, pull all the structure, basically take it from semi-structured into properly structured tables. And then we will pass that into an Azure Data Factory pipeline, taking advantage of its upsert feature. And then we'll split that out into a number of other tasks that will aggregate that into the downstream database. I know I've been kind of speed talking. Any questions up to this point? How many people here have written Python scripts before in any capacity? Cool. Are those the main, is that the main language that you guys use, or is it more just like for side projects?
At work, I use like Python, PySpark. So
Awesome.
I use some Perl.
Perl, yes. Awesome. So we'll take a look at the code real quick. This particular pipeline is a little bit more complex than one that I would typically show somebody seeing Airflow for the first time. But it touches a lot of different Azure data services, and it's designed to illustrate a lot of different DAG capabilities. Most of the time, your DAGs won't be this complex. So at the top, you've got all of your imports. So we're importing the WASB hook for the Blob Storage. We are calling the async operator for Azure Data Factory to execute that pipeline. These are just the imports that allow us to talk to those Python modules. We've got a list of the City Bikes locations that we're interested in. And then jumping down a bit, this is where we're pulling the API results for each location. So we're using the Python request module to call API.CityBikes v2 networks, and then we're passing in the provider for that location. We'll create a blob path name, and then ultimately we use the Azure hook to load that into our blob container. Make sense so far? Awesome. So then once we do that, we call the Azure Databricks submit run operator async And what that does is it takes the Databricks connection ID that we created and a JSON structure that passes in the notebook ID and the operation that we want to perform in there. If we flip over there, quick look at that. We'll see we're using the ABFS. This is like the Hadoop compatible driver into Blob Storage and constructing the path where we want to put that output the file basically, or where the file was output. And here we see where all of that raw REST API results came back in. And then we'll use the Databricks EF parser to define kind of the structure that we want to pull out of that JSON data. Then you can see the tabular results that we get from that. And in this case, it's sort of like there's like JSON inside of JSON. So some of that parsed into columns the first time, but then on the byte locations column, there's still JSON embedded inside of there. So we'll do another round of extraction. We can pull out the subfields inside of there and alias them to the column names that we want them in, and then cast them to the data types that we want them to be. And do some more aggregation there. And then ultimately, we will take that structured data now and we'll write that out to a CSV path back into Blob Storage. So the main idea, the way that you structure your pipelines is you want to take like each task for each part of the work that could fail or that you would want to be able to troubleshoot or retry. You put those in their own tasks. And then within the Airflow framework, if you have a task failure, you can go back and selectively re-execute that task. And then when you do that, Airflow automatically knows what other tasks based on the inherent dependencies need to be executed then with the new output data outputs from those. Any questions?
I have a question. I noticed there that this thing was supposed to run and look at the data every 10 seconds to see what, if there's new data or if the data has changed or what?
Well, let me take a look back at the schedule. Were you saying in Databricks that you saw 10 seconds or on the Airflow side?
I don't remember where I saw it, but I'm just wondering if is this more for a data stream or is something that changes occasionally and
Yeah, that's a great
you just go look at it and when they change it, do they just put the changes or do you get the whole thing again or what?
Yeah, so that depends. A couple of questions in there. So in terms of like the frequency of operations at Airflow, it's really initially designed for recurring but not super frequent batch operations. So something that runs like every day, every hour, every week, that kind of thing. But you certainly can run it as often as every minute. I mean, the scheduler allows you to schedule it down to like every second. But with the latency that comes with executing the tasks in the pipeline, I would say generally anything that's going faster than like once every 5 minutes is probably not a good fit for Airflow. In terms of handling streaming data, it kind of depends on the streaming service or the streaming data that you're using. You can schedule it to run fairly frequently and pull out batches from queues, but it's not really designed as a streaming data processor initially. Like people certainly use it that way, but it's kind of like a little bit of an off-label use.
Again, are the batches normally batches of everything and it just processes that, or is it batches of changes or updates or what?
That's really up to the pipeline author. Because you're writing code, you can either write code in raw Python, so you can create the specific queries you want. A lot of times, like with a SQL query, you'll use a template where you'll just pull out data for the particular time frame that you're running on. So like if you want your pipeline to run every hour, at the top of the hour, you would construct the query to pull out like the last now minus 60 minutes or whatever. But it's super flexible. I'd say that's one of the downsides of Airflow, is that it's so flexible that it's kind of easy to create foot guns if you don't have discipline around like how people are writing code. And that's the main idea of the operator, is that as much as possible, we want to like encapsulate the commonly executed tasks so people aren't having to reinvent the wheel all the time. Yeah, great question. All right, so far we've seen that we've pulled the public API data, and then we've converted it from semi-structured to structured. So now we've got a CSV file sitting in our blob storage. Then we're going to call the run upsert pipeline in ADF. And you may notice that our Databricks operator and the ADF operator both end in async. And what that means is that for long-running jobs, Airflow will make an API call like into ADF to kick off a pipeline execution there, but it's not going to wait around for it to complete. So when you're thinking about scaling for like really large organizations that have thousands or tens of thousands of pipelines running, it makes a really big difference. If you're going to run an hour-long Spark job, you don't want to be holding your worker slots like open in your scheduler. So that's a really cool feature that was just recently released that for a lot of companies are increasing their Airflow throughput like between 4 and 10x, depending on the nature of their pipelines. So something that maybe, say took $4,000 a month in compute before is now only taking $1,000 or even less in compute using the async operators. Sorry, Adam, I don't know if I shouldn't have said that part or not. But yeah, so we're always like aiming towards more efficiency, right? Of making things work as good as they can. So if you take a look at the ADF pipeline itself, this is actually a very simple one. We're just using the upsert task in ADF. We've got a data source already configured. That's the base prepped. That's our CSV file. And then we're going to take and using ADF's upsert capability to combine either an insert or an update, depending on whether the row or the record already exists. It'll load that into the bike availability Postgres database. So relatively simple pipeline there. And then from there, we again break out into the different randomized locations and run all of these in parallel, or perform some additional checks, like data quality checks. So things like, is the data set that we're working with above a floor that we care about or below a ceiling? One of the big challenges that people, when they're running data pipeline space, is quality issues. Oftentimes the pipeline may be working right, but maybe your data set that you're ingesting is generated by some other team who you don't even have a relationship with. So you need to be able to know, is the data you're getting, does it meet the parameters that you're expecting? And then you can also run those same kinds of quality checks on data you're outputting, so that if you are producing data products for other teams in your organization, if there's a problem, you'll know before they call you, right? It's like if there's a problem with what you manage, you want to have kind of like proactive monitoring so that you can go in and fix it. Particularly, the more data-driven companies become, the more revenue is based on that data, and you don't want to be the one under the spotlight if something went wrong over the weekend and a C-level person is expecting a report and it was your pipeline or your data set that blew up, and is going to cause problems for them. So that's kind of the pipelines in a nutshell. Again, one of the big benefits of this is if you've ever had to either maintain somebody's code, which is a nightmare, or maintain an undocumented set of cron jobs that are spread between different VMs, or maybe the VM, that actually happened to me. It's embarrassing to admit. I had a TLS monitoring cron job set up on a machine that my vault certificate expired over the weekend, and yeah, it was pretty embarrassing. But the main idea is that Airflow makes it really easy for people to understand what the pipelines are doing in their environment without having to go read through a bunch of low-level code, or they'd have to read a bunch of like Java application logs on some file system somewhere on a machine that you don't even necessarily have SSH access to. Right. So that's this Azure data pipeline kind of an overview. If you want,
yeah, I have a question, Jacob. So in terms of like sharing this, is there like a DevOps story for how others might have access to what you show amongst team members?
Yeah. So you mean like from like a code development lifecycle? Yeah. Great question. So that's another benefit is Airflow is designed as a code first solution. So all the pipelines are defined as code. Everything that you do really happens either at a code or API level. And the intention then is that following the general DevOps model is that you version control all of these things. And so all of your DAGs would be checked into, let's say, a GitHub or an Azure DevOps repo. Ideally, you would have dev lifecycles. So you would have like dev environments for your Airflow dev environments for the developers to do their initial coding in. They would then check that code into a staging branch on a repo. The Azure DevOps pipeline could pick that up, push that to your staging Airflow environment where you can run automated tests. And then if everything passes there, you would roll that up to then a prod, or merge the code changes into the prod branch, and then that automatically gets pushed up to the prod environment. We're in the process of improving the CI/CD story. The deploying DAGs from local dev up into production environment is pretty straightforward. It's just the astro deploy command. So invariably, most people's pipelines just look like, you've got like an astronomer API key, and then astro deploy will push the code to the deployment that's associated with. I think we actually just like maybe yesterday released a specific GitHub action that takes the burden off of you from having to even go through the process of installing the Astro CLI in the pipeline environments. Great question. So I asked earlier, was there another question?
Lots. So this gets triggered by something like when there's a data available in some place, say service bus or.
That's a great question. So the core way that most people schedule their pipelines is with Airflow acting as the scheduler. And if we look at the main DAGs view, you can see in the schedule column, there's a variety of ways that you can do that, either with cron expressions or Python datetime objects. You can also do composite schedules. So based on data sets. So we've got a concept that we just added in Airflow called data sets, where the pipeline will execute when a data set is updated instead of like on a clock schedule. Because a lot of people would have one DAG that would run at a certain time, and then, but it's a really big DAG, so you kind of want to break them apart and keep them separate. And then they know that this one, okay, this usually finishes between like 4 and 5 a.m. So we'll just wait a while and we'll schedule the next one to start at 5:30. But with data sets, you can essentially you're defining a label that creates a named data set. And then anytime one of the other pipelines updates a data set that you're subscribed to, you can kind of think of it like PubSub, but there aren't actually messages being passed around. It's more just like for the purposes of scheduling. In this one, we've got one schedule called composite schedule. I've got 3 different DAGs that update that schedule or that data set. And then I've got a DAG called DAG on composite schedule. And so the reason I put this one together was a customer, they were saying, we've got these really complex schedules where we need like 4 or 5 different cron expressions to capture all the times that it's supposed to run. And so for that, we've got the top one here. This is like Wednesdays every 5 minutes, Monday through Friday every 6 minutes, and then noon on Sunday. All right, so that's, you can't like write that with one cron expression. So that's a way that you can build more complex time-based schedules. But I think maybe the real question that you're asking about data sets though is like, is Airflow aware enough about a data set to notice that it was updated on its own and then kick off a pipeline? Sort of like yes and no. There are a variety of sensors, and a sensor is something that's looking for a change on a particular object. But that's generally not something as rich as like an entire data set. It's more like I'm going to look for a blob key to be created or to be written to, or for it to not exist or something like that. So in that scenario, you would need to define the upstream operations that work on that data set to drop an indicator. Like whenever that data set is done being written, we're going to create a blob object that's going to match this pattern. And then Airflow can watch for that and then use that as the trigger. So it's possible, but it's not as robust as it will be eventually.
You can bring in your own custom code as well.
Yeah, absolutely. So all the operators there are designed to make it easier to get what you need done faster. But you absolutely can write everything in raw Python 100%. There's a Python operator where you can put whatever Python code in each task that you want. And you can also write your own custom operators.
What about other languages?
Oh, good question again. It depends on the executor. But if you're running on Kubernetes, there's one called the Kubernetes pod operator, which will just kick off a Kubernetes pod based on a container image that you define. So you could create a container image that has whatever tooling and languages built into it, and then you would just pass in the task parameters that would be fine.
So in your experience, when do you prefer Airflow over logic apps or vice versa?
Over what?
Logic apps, do you know Azure logic apps?
I'm not familiar with them, no.
Oh, okay. The reason I'm asking is maybe 6 months ago, I did a project for one of our clients, and we ended up replacing Airflow with logic apps. And they have very similar functionality. Azure Logic Apps is our own product, Microsoft. And that, part of it was familiarity. I had used Airflow about 3-4 years ago. It's come a long way since then.
For sure.
But we tried to architect around Microsoft toolings. The customer was running into throughput problems with Airflow, which we were, and mind you, I have no particular bias here. I learned Airflow before Logic Apps, so, and I like it a lot. I'm just trying to see what is your experience.
Yeah, so in that time frame, there have been really massive performance improvements on the Airflow side, like from 1.0 to 2.0, and then we're up to like 2.5 now. And there's a lot of ways that you can run into performance problems. Airflow was designed to be a highly scalable solution for data orchestration, but there are certainly things that you can do even with the current version that can cause performance problems. So like one thing is if you're passing large amounts of data from task to task, like in the pipeline that we looked at, each step was putting its data set into like Azure Blob Storage.
Yes.
And that's where all of the big data is going to be. It's possible you can pass basically the outputs of one task into as the input of the next task, just by returning a Python object. Like you can have some big data set and just say return whatever, and the next task will pick that up. Depending on the XCOM backend that you're using, that can cause problems. So by default, all of the data passed between tasks goes into the Metastore database. And that's a traditional Postgres database. So if you're going to be like, ramming like 3 gigs of data or 10 gigs of data or whatever in there, like Postgres is generally not going to like that. What you can do like in that scenario is instead of having Postgres as the XCOM backend, you can say, we want to use Blob Storage as the XCOM backend. Then Airflow will transparently, anytime you return a Python object from one task, it will serialize it, put it out as a blob, and then the next task, when it starts up, it will deserialize it and pass it in. So that can help quite a bit with that. Other scenarios where, so is Logic Apps, is it like a pure like defining pipelines as code, or is it more of a graphical?
It's a graphical environment. And at the highest level, it's a workflow orchestrator, same as Airflow. So that's where I was coming from. I was asking whether you have done any sort of comparative analysis between the two. My team being Microsoft, we ran with everything Microsoft. But I have known Airflow for the last 3-4 years, haven't continued working in it since then. It's a nice tool, and I can see that they overlap quite a bit. Though we have a slightly different approach in terms of graphical tooling and everything. The integration with other Azure services is very good. It has to be.
Yeah, so I think there certainly is, like you said, it sounds like there's a lot of overlap in terms of their capabilities.
Yes.
Maybe the audiences are probably a little bit different. And so one of the ways that Airflow struggles is that you pretty much have to have Python developers on staff to build the pipelines. We've been doing a lot of things to make that less so. Like the more capable the operators get, the less Python code you have to write. We have a cloud-based IDE that's like a Jupyter notebook that allows you to have a very simple, like, just drop some SQL queries or very small Python snippets into the notebook cells. And then on the back end, we'll automatically generate the full Python code for the pipeline. So if you want to have like the business intelligence people or somebody who maybe just knows SQL, that gives them the ability now to write pipelines without having to get like way down in the weeds. But it really, from the organizations I've talked to, they tend to either be kind of one or the other, or they'll have different camps of people who are very much wanting to do one model or the other. Like if you have an organization that's like hardcore in on DevOps, everything is code, then they're gonna be staffed with people typically to do Airflow. But yeah, we have this ICP, not insane clown posse, but ideal customer profile. Identifying the customers that are a good fit for the product. And definitely this is where I think also, like if you look at like Airflow and Azure Data Factory, they're both very much data oriented orchestrators. And I don't really see it as an either or. For a lot of organizations, they're going to have people who want to build in ADF. And at the same time, you're going to have other people who want to build in Airflow. Maybe if they're, you've got a team of Python developers. And the cool thing is that, they can talk to each other. And I expect that the Azure integration is just going to continue to get better on the Airflow side.
That's a great answer. I have a follow-up question for you though. How often do you use Airflow alongside Kubernetes? Do you use Kubernetes with Airflow or you don't?
Well, me personally, no. Yeah, no, that's another great question. And the answer is it's absolutely yes. It's kind of a complicated answer because like a lot of things in the open source world, there's so many different ways to do it.
Yes.
The open source Airflow project has a Helm chart where you can go and deploy Airflow into Kubernetes relatively easily. And that's sort of, if you want to operate in the Kubernetes world, that's the way that people typically recommend doing it. Your pipelines don't have to be Kubernetes aware at all to do that. But if you are running on Kubernetes, you can use the Kubernetes pod operator and have very much, if you want to be married to that runtime, there are some capabilities that you can take advantage of. The Astronomer platform runs on Kubernetes, like it's all in the control plane is all in AKS. And then when our customers deploy our managed Airflow, we're doing that down into Kubernetes namespaces inside of the AKS clusters.
Great.
Although we're actually not using the Kubernetes executor. It's kind of weird. It's using the Celery executor, and we're using a different component to scale the Kubernetes clusters up and down based on the resource utilization. I think it's called Kita or Kita's Kubernetes event-driven auto-scheduling or auto-scaling. Yeah.
Very good.
So if you guys want, I can show you how to set up local Astro Airflow dev environments, or if you don't, we can break early. Michael, that face says that you don't want to see how to set up local.
I'm the least technical person in the room, so I certainly hope that some people want to take you up on it.
So is this available on Azure from the marketplace or?
It is, but I think it's like a private offer kind of thing. It's not like we're working on having it be more automated.
Gotcha. But it can talk to Azure through various.
Yeah. So that's a good question. The connectivity is interesting. So I think with AKS, you guys just recently released the ability to do Kubernetes namespace level identity type connections. So like Azure, you could authenticate to Azure AD using the Kubernetes service account token inside your namespace. Prior to that, and Adam, correct me if I'm wrong, but I think there was like a pod level identity that you could work with, and we didn't support that because we were looking for more of like the namespace level one. And now that that's available in Q1 sometime, we're expecting to have that there. So like the way that your pipelines authenticate to Azure right now is not ideal. You just have to put a service principal, client ID, client secret, app registration, static credentials, and most organizations don't like doing that because they've got policies that they've got to rotate secrets every so often. And there is Vault integration, but most companies that I've worked with are still relatively early in their cloud modernization journey and doing like orchestration as code with dynamic service principles from secrets manager. Like it's too much for most people, but it is all possible. And as soon as we get the Q1 feature built around the latest AKS identity management, then it'll be even better because in that scenario, you basically just create a policy like give permissions to this AKS namespace service account to whatever Azure services you need. And then the pipelines will just automatically use that transparently without any static secrets that customers have to worry about rotating.
Basically, an identity for a pod is what that feature would be. It's going to be much better. Right? GAs.
Awesome. So does anybody want to see how to set up a local dev environment, or I can just talk about it real quick. Essentially, what you need is a local Docker on your workstation. You could either use Docker Desktop, or my preference for a variety of reasons, if you're on Windows, is to use WSL, the Windows subsystem for Linux, and then you install Docker CE inside of that. It works like way better than Docker Desktop. Uses less memory. It's rock solid, reliable. And then as long as you have access to run the Docker command in your shell, you install the Astronomer CLI, and you can do an astrodev init. It'll create a project, astrodev start, and it'll load up all of the containers that you need. And then I have a GitHub repo.
What you just described, Jacob, was spin up the UI you were showing us this evening.
Yeah, so this will, the repo is called Astro SuperDev. I called it that because it's like Astro Dev, except it's super. It adds a handful of things. So it puts HashiCorp Vault in there for dynamic secrets generation. It does a stats exporter for getting stats out of the environment, because Airflow is kind of a complicated tool and you want to be able to understand how all the different pieces are working. Then Prometheus for gathering all those metrics, and then Grafana with Grafana dashboards built in, so you can see all of the stuff there.
How much monitoring should people be using with this once things are running?
I would say it's still pretty important. Like, it's not the kind, I mean, depending on your data sets and your pipelines, like if your pipelines aren't changing and your data sets, like the data sizes are relatively constant, then there's not that many things that will go wrong. But if you have like a big influx of data, that can, cause scalability issues if your Airflow cluster isn't set up to scale. If you're doing like dynamic task mapping, where you spin up a number of tasks to process the data in parallel, depending on the data size, like you could, run out of hardware, so things like that is important. Some customers have, or actually open source Airflow users that I've talked to have run into problems where they've got, several thousand tasks running concurrently on their cluster. And then what happens is the scheduling delay starts to build up. So like you have a DAG that was supposed to start at 10 a.m., but it didn't execute until like 2 p.m., which, for certain use cases is pretty problematic.
So in those types of cases, would separate installs of the product to handle certain parts of it solve that issue?
Yeah, definitely. So the approach that Astronomer takes, it's like we've tried to design as much as we can the Kubernetes scaling setup to just work dynamically. But if you don't have that, or if you have maybe one set of pipelines that are super important, and then another set of pipelines where it's like the Wild West and people are doing all kinds of crazy things, it's kind of like a prod, non-prod. You want to isolate those as much as you can. So like separate Airflow deployments. You can, with Kubernetes namespaces, like we run them multiple Airflow deployments, each in their own Kubernetes namespace. But you can have like multiple AKS clusters with like critical stuff on one and more risky stuff on another one. And that's why having the local dev environments is really important also. I've been shocked to the number of existing open source Airflow users I talk to, where they have like for the whole company, they have like one Airflow deployment and everybody like pushes their code to it and everybody has their data going in and out of there.
Like on one VM somewhere.
Yeah, either like one big VM, or maybe they've got like one Kubernetes cluster that it's running on, and everybody's scared to do anything because they don't want to be the one person who breaks it, right? And so that just slows down the pace of innovation because people are afraid to. You really want everybody to have their own environment, so they can work fast and break things that don't matter, as opposed to breaking things that do matter.
Questions? Any questions for anyone online? We've been monitoring the chat, haven't seen any. You come off mute and use your mics if you would like.
Awesome. Well, hey, everybody, I really appreciate y'all coming out, and any questions on my contact information is outside. So thank you.
Many thanks. Thank you. Thank you all. Thank you all for coming out. Yeah, and again, many thanks to Jacob for teaching us. Who learned something? Yeah, I learned something. That was kind of interesting, which is a result as far as I'm concerned. So, all right. Thanks everyone again for coming out. So we actually have managed to I don't use it, but I've succeeded in planning next month's already, which is amazing. Next month we have Red Hat coming in, a couple of architects based here in Texas, one's in Houston, the other's in just up the road in Austin. They're going to talk about the Azure Red Hat OpenShift Kubernetes offering that we have in Azure. Like everything you wanted to know and didn't want to know about. Good, bad, and ugly. We'll talk about that. So I hope to see you all both online and in person at that next month. Thanks all for coming out.
Thank you.
Thank you.